Okay, we spent a little time going through the mechanics of 10's complement and 2's complement. And the idea is that we were going to get to signed numbers. And when we talk about signed numbers, we have choices. We have positive numbers, we have negative numbers, and we have zero. Okay, so one of the advantages of 2's complement is there's a single representation of zero, so we really don't have to worry about zero. For positive numbers, it's really pretty straightforward. So let's say I had 4 bits to represent a signed number. The range of bits that I can represent is 0 through 7. Okay, so I go through here and I represent these, but by the time I get to 7, I need that 4th bit to represent the magnitude. But with signed numbers, the most significant bit is the signed bit. Okay, another way to think of that most significant bit is to think of the most significant bit position as negative 2 to the n minus 1. So in this case, we have 4 bits. So 2 to negative 2 to the 3 is minus 8. Okay, so let's take a look at encoding a number that's negative. That's the interesting case. Let's encode, let me reset this. Let's encode minus 5. Okay, so with minus 5, we know it's a negative number. So our process is to, first of all, take the magnitude of that number. So 0, 1, 0, 1 is 5. Okay, then we flip every bit, and then we add 1. Okay, so that's what we get here. And that takes us back to what we had when we started with this discussion. We had 1, 0, 1, 1, or minus 5. Okay, so that's the number. A good way to check that is you can take 2 to the n. All right, so I take, I'm sorry. Yeah, 2 to the n is minus 16. All right, and then 1, 0, 1, 1, that's 8 plus 3 is 11. 11 minus 5 is negative 5. So that's a good way to check your result using a different technique to get to the answer. All right, so I like to close the loop with that and make sure that I got the right answer. Okay, so again, just to reinforce the point, one of the reasons that we like 2's complement is that we can do subtraction. Subtraction is built into the representation, and we can do subtraction with addition methods, with an addition circuit. Okay, so in this case, if I added these together, 0 plus 1 is 1. You don't have anything to carry. 1 plus 1 is 0, carry the 1. Then we have 1 plus 1 plus 0 is 0, carry the 1. 1 plus 0 plus 1 is 0, carry the 1. And the 1 gets over here in the extra bit position, and we can ignore that. Okay, so in this case, the answer would be 1. Okay, so what we're doing here is we're doing 6 minus 5. Another way to think of that is 6 plus a negative 5, and we know the answer gives us 1. Okay, so I want you to play around with this. This is representing signed numbers. You can encode a number. By the way, positive numbers are easy. For a positive number, if I want to encode 5, I just convert that. All right, I do the magnitude. The magnitude of plus 5 is 5. Because it's a positive number, I can skip these 2 steps that involve the 2's complement, and I get to my answer right away. Okay, so those cases are easy. What I also want you to do is take a look at the range of numbers. Okay, so I'm going up here and I'm going to 5 bits. All right, so let's go to the initial landing page on this infographic. With 5 bits, here are all the possibilities. Okay, so if I wanted to represent 7, all right, I take the 5 bits. All right, 7, the magnitude of 7 is 1, 1, 1, okay? And because it's positive, I don't have to worry about any signed bit. The signed bit is 0. The MSB for a positive number is 0, okay? And so then over here, what about, say, minus 14? Okay, so with minus 14, I can think of that as the sign bit kicks on because of the negative bit, and then I add minus 16 plus 2, and I get to minus 14. Okay, so that's one way of thinking of it. if you wanted to encode a number using 5 bits, the process is similar. Okay, we can do -7 in this case because -7 fits into 5 bits. All right, so if I did 7, all right, let's start. The magnitude is 0, 0, 1, 1. I flip every bit. I add 1 to it. I get to my answer. Okay, I can check that answer by converting this to decimal. So 32 plus 16. I'll get this right. 16 plus 8 plus 1 is 25. Okay, so 25 minus 32. This is the 32-bit or 32 place. So 25 minus 32 is -7. Okay, again, you can subtract by adding. Here's an example of 6 plus a -7. Okay, so when we add these together, you go through this process. Look what happens in this case, though. There's no carry out into that sum, so this stays with it, all right? And we get the sign bit being negative, which makes sense because 6 minus 7 is -1, all right? And if you go back to here and look this up, all ones here is -1, so it makes sense. All right, so I'd like you to play around with this infographic so that you understand the process and so you can visualize what happens as you add bits. Okay, so if I go to 16 bits, you can play around. The thing to think of is what is the range of values? Okay, so for 6 bits, I can go all the way up to 31 for the positive number and -32 for the negative number. We'll talk about this in class, about the range of signed numbers, but this is the overview of how to make signed numbers work for you.